And today I'm going to start with the nth roots of unity. Good evening, everyone. Good evening. So the next concept that we are going to talk about are the nth roots of unity. Okay. You can take this concept as a more generic case of the cube roots of unity. So cube roots of unity that we studied in the last class towards the end, you can think that it is a special case of this. So this is a more broader version of it. Okay. So when I say I want to find out the nth roots of unity, means the number 1, that means I'm expecting n answers to come out of it, correct? And these n answers are basically your nth roots of unity. For example, when you do cube root, you get 3 answers. So you call them as cube roots of unity, right? So in a similar way, when we find the nth root of unity, we'll get n answers out of it. So n different roots will come out of it. And those will be called as the nth roots of unity. Okay, so how do you find this out? Now, very simple. We'll be following the same process as what we had learned in our de Moivre's theorem. So 1 is a complex number, we all know, can be written as 1 cos 0 plus I sin 0. Okay, and when you're raising it to the power of 1 by n, that means you're raising this to the power of 1 by n. Okay, as per the de Moivre's theorem, this will become something like this. Okay, and the next step is like we will multiply this to the argument of this. So multiplying this to this number, I'll get 2k plus 0 into 1 by n, which is going to be this. I sin 2k into 0 into 1 by n. Okay. No, this is the first slide, Akash. So pay attention from now, and please do not join late. People are joining late. I don't know why. The class was supposed to be from 3:45. Okay, so if you are joining a minute late, you are missing out on the initial plot. Right. Now, what did the Moivre's theorem say? In order to get the answers, you have to put your k as n consecutive integers. N consecutive integers, but we preferably use 0, 1, 2, all the way till n minus 1. Right? Yes or no? So when you put 0, you'll end up getting the first root as, let me write it in yellow, cos 0 plus I sin 0. That itself is a 1. Right? So it's very obvious that one of the nth roots of unity is going to be 1. Okay. If you put k as 1, you'll end up getting cos 2 pi by n plus I sin 2 pi by n. Okay. Let's call it as alpha 1 for the time being. Okay. When you put k value as 2, you get cos 4 pi by n plus I sin 4 pi by n. Right? Let's call this as alpha 2. Okay. In a similar way, if you continue putting the values of k, for k equal to 3, you'll end up getting cos 6 pi by n plus I sin 6 pi by n. Let's call it as alpha 3. And till you go to k value as n minus 1. And that would give you cos of 2n minus 1 pi by n plus I sin 2n minus 1 pi by n. Okay. This can be termed as alpha with a subscript of n minus 1. Right. Now, if you observe this very carefully, you would realize that alpha 2 is actually the square of alpha 1. Yes or no? Alpha 2 is actually the square of alpha 1. Why? Why? Can anybody answer that? Can anybody answer that? Yeah? No? See, because if you square this term, if you square alpha 1, you'll end up getting cos 2 pi by n plus I sine 2 pi by n whole square, right? And as per the de Moivre's theorem, this will become cos 4 pi by n plus I sine 4 pi by n, because this 2 will go and multiply to the argument, isn't it? So when this 2 multiplies to the argument, doesn't it give you cos 4 pi by n plus I sine 4 pi by n? That's nothing but alpha 2. So this is nothing but your alpha 2, correct? And to add to it, you will realize that alpha 3 is the cube of alpha 1. Similarly, alpha 4 will be fourth power of alpha 1, and so on and so forth, right? So what do we normally do is, we call this as alpha, and then we start calling this as alpha square, alpha cube, da 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 da, and this we call it as alpha to the power n minus 1. So as to say that these cube roots, sorry, not cube roots, these nth roots are actually in a geometric progression. Yes, the nth roots of unity are in a geometric progression, right? So you can note down, very important, the nth roots of unity are in geometric progression. Is that fine? Any questions here? So those who join in late, first of all, a straight away warning: if you are missing out on the initial part, you are missing on the plot. And if you're missing on the plot, then at least for the plot to change, it will take half an hour or 45 minutes of the class. So you have to sit like a person who is not understanding anything for 45 minutes. Never join late. If at all your system is going for an update and you know it's going for an update, it happens in window. When you switch on your laptop, it goes for an update for half an hour. It's better to check your laptop at least half an hour or 45 minutes before the class. Last time somebody joined 45 minutes, they are saying that his laptop went for an update. So these technical glitches can come. That's why I use Linux. People are still joining. Oh my God. Is this fine? Any questions here? All right. Now, you can figure out this in a very simple way as what we had discussed in the last class. Geometrically speaking, or you can say geometrical position, or you can say geometric interpretation of the nth roots of unity is, you normally have the first root, which is located at a distance of, remember your last class what I had discussed, that if your complex number is r cos theta plus I sin theta, and you're finding the p by qth root of this complex number, your first root will be located at a distance of r to the power p by q and at an argument of p by q theta. Do you remember this? Correct? So if you try to apply the same concept over here, r is 1, okay, p is 1, q is n. So first root will be located at a distance of 1 to the power 1 by n, which is actually 1, and at an angle of 1 by n into 0, which is 0. So first root will be located at 1 over here. Okay, so you can say 1 comma 0 will be your first root. Now the subsequent roots are located at the very same distance, that is 1 to the power 1 by n, but you have to keep adding 2 pi by n to the previous argument. So previous argument was 0 into 1 by n. So the next root will be located at, you can say, this position. So let's say this is Z1, this is Z2. And this angle difference is going to be 2 pi by n. Okay, this distance is still going to be 1, 1. The third will be again located at a distance of 1 from the origin, and again at a further change of 2 pi by n. Okay, so this will be Z3, right? So it will keep on, you can keep on listing down these roots on the ARGAND plane, right? Dot, dot, dot. I'm not going to draw everything. So if you connect them, if you connect these nth roots of unity by straight line segments, you will end up getting a regular polygon. Okay. So like that, if you start connecting it, so this will be giving you a n-sided regular polygon. N-sided regular polygon. I would request you to compare this case with the cube roots of unity. In cube roots of unity, if you recall, when we placed the cube roots of unity on the ARGAND plane and connected them, we got a equilateral triangle. Equilateral triangle is actually a special case of an n-sided regular polygon. That means these side lengths will all be equal. Are you getting my point? So a lot of questions can be framed on this. For example, you may be asked a question that what is the side length of of the regular polygon which you obtain by connecting the nth roots of unity. You may be asked the area of the polygon. You may be asked the radius of the circumscribing circle or the circumcircle. You may be asked the radius of the incircle. So many questions can be framed on this. So you should be ready with this particular aspect. Okay. So is there any question with respect to what are the nth roots of unity? So for those who joined in, please note this down. So these are your nth roots of unity. And as we discussed here, these nth roots of unity would be in a geometric progression. And in that geometric progression, the first term is 1 and the common ratio itself is alpha. Is this fine? Any questions? Any questions with respect to this? Please do let me know because I'm going to change the slide. Yes, somebody has a question. Just a minute. Dear all, unless until notified, your classes are going to run from 3:45 to 7:30. So please do not forget that. Some of you are still joining at 4 o'clock thinking it's a 4 o'clock class. No. As you know, we have a lot of grounds to cover. That's why we are starting in early. Just take a snapshot, Charan. You can copy it at your own pace. Okay. Let not others wait for you copying down. Yeah, only for the roots of unity. Yes, yes, only for the roots of unity. If you check your 1 omega square, isn't this forming a GP with first term as 1 and common ratio as omega? Okay. For other cases, normally you will end up getting P 2 pi by n plus P theta by Q term, right? So that disturbs your GP formation. That disturbs your GP formation. Here, thankfully, you had a 0 in the initial to begin with, right? So when you are continuously increasing it by 2 pi by n, you basically having the square, cube, etc. of the same complex number alpha. That's what makes it a geometric progression. But the same cannot be found if you are using any other complex number whose initial argument to begin with is not 0. Okay. So I'm not saying that is only for unity, but yes, for all those cases where you are starting with some nth root of a quantity which is having the initial argument as 0, in order to say that you have to have a real positive quantities nth root to happen in that case. So for such cases, it will be in GP. All right. So now we'll talk about the properties of nth roots of unity. Roots of unity. The first property is the sum of all the nth roots of unity is actually going to be 0. Why? Okay. The proof of this is very simple. If you start writing alpha 1 as alpha, alpha 2 as alpha square, alpha 3 as alpha cube, and so on till alpha to the power n minus 1, you know that it's a geometric series. It's a geometric series. Okay. So what is the sum of n terms of a geometric series? Sum of n terms of a geometric series is a common ratio to the power of n, n being the total number of terms, minus 1 by alpha minus 1. Correct? Now, because alpha to the power you can say for the reason alpha is the nth root of unity, alpha to the power n is going to be 1. So alpha to the power n minus 1 is going to be 0. So this whole thing that you see here, this will become a 0. And if this becomes a 0, the sum will become a 0. Okay. Another way to look at it is, if you see the n roots of unity come from this equation. Correct. So the same thing, I'm writing it like this. Correct. You may treat as if you have written z to the power n, 0 z to the power n minus 1, again 0 z to the power n minus 2, till minus 1 equal to 0. Okay. And this equation has roots 1, alpha 1, alpha 2, all the way till alpha n minus 1. Right. Now from beta's relation, what is beta's relation? We have already done this before. Beta's relation says that the sum of all the roots of any polynomial equation is nothing but minus b by a. This is your b and the 1 over here is a. So it's 0 by, or you can say minus 0 by 1, which is anyways going to be 0. Okay, this is another way of looking at it. Now what is important is a very important takeaway from this, or you can say a corollary from this, which says that if you sum up cos 2k pi by n from k equal to 0 to n minus 1, this will be 0. And if you sum up sine 2k pi by n from k equal to 0 to n minus 1, this will also be 0. Now, how is these two things related? You must be thinking, ayyo, there is some sum of roots happening over here, and all of a sudden, sir has brought trigonometry here. Can anybody relate this to the previous result? Why this sum of the cosine series of the nature 2k pi by n from k equal to 0 to n minus 1 is 0, and why sum of the sine series from k equal to 0 to n minus 1 equal to 0? Can anybody relate this result to the previous result? Right. So yes, so basically what I have done is, instead of, okay, so let me write that result once again. Okay, so this was the result, isn't it? So what I did was, I wrote 1 as cos 2 into 0 into pi by n plus I sine 2 into 0 into pi by n. Okay, don't treat it as 20 pi by n, it is 2 into 0 into pi by n. Alpha 1, I'm writing it as cos 2 into 1 into pi by n plus I sine 2 into 1 into pi by n. Okay, so this is your 1, this is your alpha 1. Similarly, alpha 2 was cos 4 pi, let me write it as 2 into 2 pi by n plus I sine 2 into 2 pi by n. Okay, right? So this is your alpha 3. Oh, sorry, not alpha 3, alpha 2. My bad, alpha 2. And it goes on to cos of 2 into n minus 1 pi by n plus I sine 2 into n minus 1 pi by n. Okay, and this is going to be equal to 0. Correct? Yes or no? Now, if this is 0, can I say the real part should sum up to 0, because this 0 can be written as 0 plus I0. Remember your basics, very basics of operations on complex numbers, where I told you that if you're comparing two complex numbers, the real part of left hand side should be equal to the real part of the right side, and the imaginary part of the left hand side should be equal to the imaginary part of the right hand side, right? So from here, can I say, basically I have written on the left side summation of cos 2k pi by n from k equal to 0 to n minus 1 plus I times summation of sine 2k pi by n k equal to 0 to n minus 1. This is equal to 0 plus I0. Correct? Yes or no? Now, this means individually these real terms are 0. That means this summation is 0 from 0 to n minus 1. And this summation is also 0. Please make a note of this. This result has been very widely, asked in some or the other form in the competitive exams. So please note this down. We'll take up a question on this. Is this fine? Any questions? Yes. Clear? All right. So before we move on, one quick question on this concept so that we are all happy with this and we can proceed on to the other properties. Let me pick out a question. Yeah. Let's take this question. Find the value of sigma k equal to 1 to 10 of sine 2k pi by 11 minus sine 2k pi by 11 minus I cos 2k pi by 11. So let's try to solve this question. Let me see who is able to answer this. Please put your response on the chat box. Okay, Anurag, very good. Okay, Pranav. So two different answers coming from two people. Guys, one thing I would like to highlight here, the summation is starting from 1 to 10, not from 0 to 10. So don't be in a hurry to put the answer as 0 like some of you have done. The summation is starting from 1 to 10, not from 0 to 10. Okay, Aditya. Oh, Anurag wants to change his answer. Okay, Anurag. Okay, anybody else? Anybody else who would like to reply? See, this can be written as summation from k equal to 1 to 10 of sine 2k pi or 2 pi k, whatever, by 11 minus I summation cos 2k pi by 11, k starting from 1 to 10. Okay. Now, what I'm going to do here is, in order to incorporate the result that we have just now seen, I'm going to start this summation from 0. Okay. But I cannot do it simply like that. I have to subtract the 0th term from it because I'm starting from 0 to 10. So the 0 is an extra term which I'm adding to this series, which was initially not there, right? So I need to remove it. So when I put 0 in place of k, I anyways get a 0 because sine 0 is 0, right? So we are safe with respect to the first term. But in the second term, I may have to see a little bit of problem. So when I start from 0 and go to 10, I have to remove the 0th term from this, which is basically cos 0, which is 1. So I have to remove the 1 from here. Okay. Yes or no? Now I can say safely that this guy is going to give me a 0 for sure, whereas this guy is going to give me a 0 here and a -1 over here. Okay, so overall your answer would become an I. So those who have given the answer as I, absolutely correct. Okay, so I think Pranav Dharmagadi was the first person to give this right. Well done, Pranav. Anurag, sorry, again mistake. Aritra, sign mistake again. Just check it out. Aditya also correct answer. Good, guys. Everybody should start participating. Come on, Janta, jago. Subah ho gayi. Okay, next property. I think property number 2, I guess. So the next property is, in fact, this is, let me give this as a question. The product of all the nth roots of unity is given as -1 to the power of n minus 1. Now treat this as a question. This is a property, that is fine. Let's treat this as a question. So if somebody says, hey, what is the value of the product of the all nth roots of unity? And these are your options. Okay, so I can give you option like 1, I can give you option like 1 to the power n, 1 to the power n minus 1, none of these, etc. What will you answer? Let's try to solve it as a question. Yes. So how do you solve this question? It's very simple. You all know that alpha 1, alpha 2, alpha 3 till alpha n minus 1, they can actually be written like a geometric progression like this. Okay, isn't it? Because if you call alpha 1 as alpha, alpha 2 will be what? Alpha square only. We have just now seen while we were discussing the theory. And this is alpha to the power n minus 1. Am I right? Yeah. So the left hand side is going to give you this. If you collect all the powers of alpha, you can treat 1 to be alpha to the power 0. So if you collect all the powers, you'll end up getting alpha to the power n into n minus 1 by 2. Correct? But product of the roots, there will always be a confusion about what is the sign before that, because that depends on n, no, Anurag? Okay, so it keeps on alternating. What is the beta formula? Minus b by a, c by a, minus d by a, e by a, minus f by a, da 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 da. So it all depends upon. So you have to wait for what is your plus or minus sign coming up. Okay, of course you can do it that way also, no issues, right? Now we know that alpha value is cos 2 pi by n plus I sine 2 pi by n, isn't it? So if I raise this to the power of, n into n minus 1 by 2, this will be cos 2 pi by n plus I sine 2 pi by n to the power of n minus 1 by 2. Okay, let me bring this n by 2 inside. So it will become cos 2 pi by n into n by 2 plus I sine 2 pi by n into n by 2 to the power of n minus 1, isn't it? So n gone, this is also gone. So basically n gone, 2 also gone. So you end up getting cos pi plus I sine pi to the power of n minus 1. This is straight away minus 1 to the power n minus 1. Right? Right? Any questions? Any questions that you have over here? Can we eliminate one n before we convert? As in, I didn't get you. Oh, you're saying alpha to the power n, will put it as 1. Okay, then you'll not be able to prove it, no? So let's say this question was prove that it is equal to this, right? Then you'll not be able to prove it. The problem is that. Now, one question that you should all have, nobody asked me this question. How do you know n by 2 is an integer? Because in order to use this, n by 2 should have been an integer. That means n should have been an even number. But n could be odd also, no? N could be odd also. So how do you know that n was an even that you, nobody asked this question. You should have asked this question, no? Are you getting my point? See, I'm questioning my own approach. So you should also question it, no? Shreyas, is there anything that you want to copy from here? See, I'm finding the product of all the nth roots of unity. So as per the formula or as per the discussion, we had this. So this summed up to this. And now when I'm taking it to the power of n by 2, what I did, very cleverly, I introduced n by 2 and multiplied it to the argument. Remember, that is possible only when that number n by 2 is an integer. If it is not an integer, right, it becomes a fraction, right? In fraction, I will have no two answers coming out of it. Correct. So how do I know n is even, and how does the result actually doesn't change because of this? So the answer here is, let us say n is even, then this is the case. Okay. Let n be even, then this is the case. Now I will take a case where n is not even. Okay. So let's say if n is odd, let n be odd. If n is odd, n minus 1 is even. Correct. Then in that case, n minus 1 by 2 will be an integer. Then what I will do is the same expression, let me write it again. The same expression, which is cos 2 pi by n plus I sine 2 pi by n. I will now do like this. I will take n minus 1 by 2 in the forefront, and this will become an integer. So this will be multiplied to the argument. So I'll multiply this to the argument. So see what will happen. So this will become cos n minus 1 by 2 into 2 pi by n plus I sine n minus 1 by 2 into 2 pi by n. Okay. And outside n is waiting. So what I did now, since n is an odd number, n minus 1 is even, n minus 1 by 2 will be integer. And according to De Moivre's theorem, if it is an integer, I can introduce it and multiply it to the argument of that complex number. Is that correct? So far it is convincing? No problem with this? Okay. So now let me do some simplification. This 2 will go with this. Okay. This 2 will also go with this. Okay. So let me remove this. Okay. Now let me introduce this pi by n inside. So it becomes cos pi minus pi by n plus I sine pi minus pi by n. Okay. To the power of n. Yes or no? Yes or no? Now cos pi minus theta is minus cos theta. Cos pi minus theta is minus cos theta. And sin pi minus theta is sin theta only. Correct? This is something that you have already learned in your trigonometry. Yes or no? Any questions, any concerns here? Okay. Now let me take a minus sign out. Let me take a minus sign out. And when I do so, please be informed that if I take a minus sign out, okay, this will become, so I is what? I is I cube, no? Sorry, a minus I cube. So see, if, let me write it separately. If you take a minus sign out, it becomes cos pi by n minus I sine pi by n. Correct? And if you're raising whole to the power of n, aren't you separately raising this to the power of n, and you are separately raising this to the power of n? Sorry. That is what I have done over here. This is what I have done over here. Any questions? Any questions? Sir, you forget to put the n power. Where? Now I put now. All good now? Okay. Now, last class we had discussed that even if it is minus, this n can come and multiply. Now, n is an integer, that is for sure. Okay. So that will come and multiply. So it will become cos n into pi by n minus I sine n into pi by n. N gone. So this will give you minus 1 to the power n, and this will be minus 1, and this will be 0. I0 you can say, or 0, that is fine. Okay. So ultimately you get minus 1 to the power n plus 1. Now people will say, sir, we wanted to prove it is minus 1 to the power n minus 1. Right? This is what you wanted to prove. No. You got minus 1 to the power n plus 1. That means we're not getting the result. No, don't worry. This is nothing but minus 1 to the power n minus 1 into minus 1 square. Minus 1 square is 1 only. So it is same as this. So there is no difference between these two. Okay. So hence proof. Are you getting my point? So one thing I'm not very happy with, that you are not questioning the things. You are accepting it the way I'm writing it. No, that means you're not applying your brain. When you bring a power and multiply inside without affecting anything, means your power is an integer. If your power is not an integer, then you should get, multiple roots out of it. So you should have asked me that when this n by 2 comes inside, you are assuming n by 2 to be an integer. That means n is even, but n may not be even. Right? So if it is not even, then this is the approach for it. So there are two cases that will come up, and both the cases I have dealt with. Is this fine? Any questions? Any questions? Any concerns here? Okay, so there are more properties, but again, I will take them as a question rather than giving you directly. Anything that you would like to copy here, please do so. Done. Can I go to the next slide? Anybody who has a problem, please immediately stop me. Okay. Mother wants to copy. Let me know once you're done, Madhav. We are all waiting for you. Done. Okay. Next question. In fact, next property that I would like you to prove that if 1, alpha 1, alpha 2 till alpha n minus 1 are nth roots of unity, then 1 minus alpha 1, 1 minus alpha 2, 1 minus alpha 3, till 1 minus alpha n minus 1, it is actually n. This is actually n. Can you prove this? Okay, so let me explain this to you because this may not be an easy problem for you in the first go, and this problem may surprise you also. This problem may surprise you also a bit because because of the solution. Let's see the solution. See, we all know that alpha 1, sorry, 1, alpha 1, alpha 2, etc. are basically the roots of this equation. Okay, so these equations roots are 1, alpha 1, alpha 2 till alpha n minus 1, correct? Right? In other words, can I say z to the power n minus 1 can be factorized as correct? Can I factorize z to the power n minus 1 like this? Because we know that the roots of this equation are 1, alpha 1, alpha 2 till alpha n minus 1, isn't it? Now what I'm going to do is I'm going to bring this z minus 1 down. Okay. And now I'm going to take the limit on both the sides as z tends to 1. Now most of you would be surprised. Are you limit? What is it limit doing over here? Isn't this a calculus topic? See guys, there's no now calculus and algebra distinction, okay? Every field of maths can pitch in everywhere because it's all based on, its application and logic. So there is a impermeable, there is a, you can say invisible, layer between all these, field of mathematics. So they can be used within one another. So never be under the constraint that, okay, algebra topic, calculus will not be useful. You never know, calculus can be used anywhere. The other day I was doing binomial theorem with your Kormangla batch. Yes, they have started binomial theorem, by the way. We are still not done with complex numbers. So there I used calculus to do some kind of a series and they were like shocked. Okay. So now when you take z tending to 1 on the right side, you just have to put the value of z as 1 because it's just a case of substitution. Whereas in the left hand side, you have to recall that we have done something like this in our bridge course as well. Limit of x tending to a, x to the power n minus a to the power n by x minus a. This was n a to the power n minus 1, correct? Now treat as if your x is z, okay? And treat as if your a is 1. So if you use the same formula, it will be n1 to the power n minus 1. That is nothing but n and hence proved. This itself can come as a direct question to you. Yes, yes. All your calculus fundamentals will work for complex number as well. Okay. Is this fine? Any questions? Why are we using limits here? For the fact that I wanted this term to come up. Aditya, I wanted this term to come up. So I wanted to put z as 1. But I was not getting the courage to do that on the left side because if I put z as 1, I would get a undefined expression, isn't it? 1 minus 1 by 1 minus 1. 0 by 0 was coming. Hence, I took a limiting case of that. Is it fine? But is z a function? Z is a variable. See, don't treat this as if you're looking at a complex number. Treat as if your z is a variable name. And that variable can take complex, real, whatever. I mean, real are anyways complex. Okay. So z is a variable over here. Right? So now, if you're putting a z tending to 1 on the right side, it is just a case of substitution, which will help us to get the desired expression. But in the left side, I cannot put z equal to 1 directly because your denominator will vanish. So I took a limiting case of that. Got it, Aditya? Okay, so this is a learning for us that yes, sometimes we can take a limit of the expression to get our answer. Is it fine? Any questions here? All right. Let's move on to the fourth property. I hope everybody has copied this down. No questions. Okay, let me go to the fourth property. So fourth property is again like a question I'm giving you. Let's state this statement first. If 1, alpha 1, alpha 2 are nth roots of unity, okay, then 1 plus alpha 1, 1 plus alpha 2, da 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 da. This is equal to 0 if n is even and 1 if n is odd. Now, the proof for this is exactly the same way as how we did the previous question. So I would request you take a minute, try it out. Exactly the same. I just want to see what value of z you put now. Okay, so till this point, everything would be the same. Z to the power n minus 1 by z minus 1 is z minus alpha 1, z minus alpha 2, z minus alpha 3, all the way till z minus alpha n minus 1, right? Now put z as minus 1. Okay, put z as minus 1. If you put z as minus 1, it becomes minus 1 to the power n minus 1 by minus 2. And this side you get minus 1 minus alpha 1, minus 1 minus alpha 2, minus 1 minus alpha n minus 1. Okay, guys, whatever I am writing over here, this is an identity. So you can put z value as minus 1 over here as well. Are you getting my point? So now, if I take a minus 1 common from each of these terms, I will get minus 1 to the power n minus 1 and 1 plus alpha 1, 1 plus alpha 2, all the way till 1 plus alpha n minus 1. Correct? On this side, I'll have minus 1 to the power n minus 1 by minus 2. Correct? Now, if n is even, then minus 1 to the power even number, okay, will be 1 only. So what will happen? This term will become a 0. So left hand side will become a 0. Right hand side, it doesn't matter whatever is this term. It is just going to be this expression. Okay. Even if it is minus 1, doesn't matter because there is a 0 on the left hand side. So you can always dissolve it. Okay. So this is the first part of the proof. This is the first part of the proof. So if n is even, the answer is going to be 0. But if n is odd, then minus 1 to the power n is going to give you a minus 1. So your left hand side will become minus 2 by minus 2. Right side will become 1, 1 plus alpha 1, 1 plus alpha 2, and so on till 1 plus alpha n minus 1. Okay. This minus 2 and minus 2 will cancel off and this give you a 1. That is nothing but the second part of the proof. That is nothing but the second part of the proof. Is this fine? Any questions? That anyways is 1, no Anurag. When n is odd, minus 1 to the power n minus 1 is minus 1 raised to an even power. Even power means it will be 1 only. Is this fine? Any questions? Any concerns here? So these properties may be given to you like a question. Okay. So the main reason behind giving you these properties is not to make you memorize this, but be aware that such questions can be asked to you as a such properties can be asked to you as a questions themselves. Let's take few questions. Let's take few questions. Okay, let's take this question. If A is a complex number given by cos 2 pi by 7 plus I sin 2 pi by 7, find the quadratic equation whose roots are alpha and beta. Alpha is given to you in terms of A, beta is also given to you in terms of A. LHS is always equal to RHS. Aditya, that's why I told it's an identity. Are you getting my point? LHS is equal to RHS. So when you're saying z to the power n minus 1 equal to 0 has roots alpha 1, alpha 2, alpha 3. Basically, what are you trying to say is that this term can be actually be written as z minus 1, z minus alpha 1, z minus alpha 2, da 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 till z minus alpha n. So this term and this term are always equivalent. That means this is an identity. So it will be satisfied for any value of z. So it is wrong to say that it will be satisfied when you are putting n as even. No, nothing like that. It is always true. But whatever you're putting on the left, you should put the same on the right. Got my point? Okay. See, when you say x square minus 1 is factorized as x minus 1, x plus 1. It's an identity, no? If you put 0 over here, you'll put 0 here also. It will come out to be the same. Right? 0 need not be a root of this equation. No, don't get me wrong. I'm not saying 0 is a root of this equation. I'm saying this is equal to this. This is an identity. Okay. So if you put 5 over here, that is 25 minus 1. This should also give you the same result. See, 24. 4 into 6, 24. So z, anything you want, you can put. I put minus 1. I can put 0. I can put 1. Okay, let's do this question. Oh, Pranav wants to do. Yes, you can put complex numbers also. See, in order to get a quadratic whose roots are alpha and beta, basically you need to get this, correct? So you can say this is a quadratic equation whose roots will be alpha and beta. In class 10th also you have studied that if you're given a root, how do you construct a quadratic? X square minus sum into x plus product, right? That has been the trend for finding the quadratic, correct? Now many times they will say you can multiply this with a k also. Okay, so that is fine. I mean, any one of the answers is fine. So you can put k also, no issues. Okay. Now, if you want sum of alpha and beta, means you're trying to add these two. So you're trying to add a square, a4, a cube, a5, a6. Okay. Now, something very important over here. If you observe this, you'll realize that, oh, this is your one of the 7th root of unity. Correct? The moment I see 2 pi by n, right, that becomes the nth root of unity, right? 2 pi by 11, 11th root of unity, 2 pi by 100, 100th root of unity, right? So this number basically tells you that you're dealing with 7th root of unity, right? So the roots, all the 7 roots will be 1a, a square, a cube, a4, a5, a6, isn't it? And we also have seen a little while ago that the sum of the nth roots of unity, n being any integer, positive integer, that's going to give you a 0, right? So because 1 plus a square, a cube, a4, a5, a6 is equal to 0, can I say this term will actually be a -1? Yes or no? Do you all agree with me? Okay. So let's multiply now. I need product also. So for product, I have to multiply. So if I multiply, let's multiply individually. A into a cube is a4. A into a5 is a6. A into a6 is a7. A7 is 1. Why a7 is 1? Because a is the 7th root of unity. So a to the power 7 has to be 1. Correct. Similarly, a square into a3 is a5. A square a5 is a7. Again a 1. A square a6 is a8. A8 is a. Then again a4 a3 is a7, which is 1. A4 a5 is a9, which is again a square. A4 a6 is a10, which is again an a cube. Correct. Can I not write this as 2 plus 1 plus a square, a cube, a4, a5, a6? Okay. So can I say this is going to be a 0? So your product will be 2. So you know the sum now, you know the product now. So who can stop us from getting the quadratic? So quadratic will be x square minus 1x, correct? Plus product. So your answer will be, you can multiply with k also, no issues. So this will be your answer. So it's k times x square plus x plus 2. Is it fine? Any questions? Any questions? This k could be any number. Is it fine? Okay. All right. Let's take another one. Where is my complex number? Complex number. This should be very easy given that we have already done a similar question. Poll is on. Poll is on. Good, good, good. I've got the answer so far. One answer, and that is correct, I believe. One minute gone. Let's have one more minute. 4 of you have responded. Okay, 5, 4, 3, 2, 1. Vote. Please vote, guys. Okay, something very interesting I would like to share with you. Most of you are not doing problems in a time-bounded manner. Okay. Your seniors also did the same mistakes. Now that we are running the crash course for them, they are very, very slow. They are sometimes taking 4.5 minutes to solve a question which can be solved within 30 seconds. Because they were not practicing it in a time-bounded manner. If you're doing that, please let me tell you, after 2 years, you will see the repercussions of that. And that will be too late for you to take any corrective action. I'm repeating, and I've been repeating this since the beginning of the course, that assignments, whatever you're solving, should not be given more than 4 minutes per question. If you're not able to solve it in 4 minutes, move on, right? Because that should hit you that it's gone. I mean, I'm not able to solve that question. Till that feeling comes that I'm unable to solve this within the stipulated time, you will not make an effort to build up your speed. Now again, with a caution, do not build up your speed at the cost of accuracy. Don't start making silly mistakes. If you're a person who is prone to making a lot of silly mistakes, it's okay to take 15-20 seconds more, but getting it right. Now this question, let's discuss this. This was not worth more than 30 seconds. We have already discussed that z to the power n minus 1 could be expressed as z minus 1, z minus alpha, z minus alpha square. Remember, I'm not writing alpha 1, alpha 2. Instead of that, I'm writing alpha, alpha square, alpha cube, etc. Bring this z minus 1 down. And as per the question, you want to get this expression, which is clearly obtained if you put z value as 11. So answer will be 11 to the power n minus 1 by 10. This will give you 11 minus alpha, 11 minus alpha square, and so on till 11 minus alpha to the power n minus 1, which is option number B. What is the big deal in this? Correct. Was it supposed to be a 2-minute question? Definitely not. It was like 15-20 seconds for a serious aspirant. Getting my point? Right? Most of you have given the answer to this as C. Why? 9 of you have said C out of 18. May I know the reason why? People who said C. Okay. All right. So with this, we'll stop the nth roots of unity, and now we are going to proceed to the next concept.